This is R.D. Sharma Solution Class 12 Chapter 19. We are taking exercise 19.26 of indefinite integrals. Now this question, erase x, sin x, cos x minus 1 divided by sin square x. First we need to devise a plan to make it as fx plus f dash x and multiplied by erase x. So when you do this erase x, fx plus f dash x integral, then erase x, fx will be the answer. Because we need a function and also we need a differentiation of that function. Then only we can prove that it is equivalent to erase x fx plus constant of integration. Now this question is not in this form right now. So we have to change the form. So we have sin x cos x. So we'll write this sin x cos x and 1 separately. And then we'll divide this sin square x here and sin square x here also. Now this sin gets cancelled, cos by sin will be cot x. 1 by sin square x, sin goes up and it will form cosec. So it will be cosec square x. Now just multiplying this with ex and putting an integration sign is equivalent to our original integral. This is your original integral because this will come just now. I will recall it in a while. Now cot x, if you take it as fx, then the differentiation of this fx will be f dash x, which is indeed negative cosec square x. So if you multiply this by erase x, fx, f dash x, in this case fx is cot x and the differentiation of cot x is directly negative cosec square x. So we can take erase fx plus c as the answer. What is fx here? Cot x. So the differentiation of cot x, which became negative cosec square x has enabled us to answer that it is just erase x fx is cot x plus c. But if we need more explanation, then we need to do more. And what is the next process? This is the overall process. This is the complete process. So those who want to do up till this, they are most welcome. But if this question needs more explanation, it carries more marks, then what you will do? See, this I is same. So we have come up to this erase x cot x minus cosec square x. So we'll take erase x fx as t. So this is erase x. What is fx here? Cot x. And this is equal to t. Now we'll differentiate both the sides. So cot x first, differentiation of erase x will be erase x only. Now erase x and differentiation of cot x will be negative cosec square x. And this is equal to dt by dx. Now we'll take erase x outside and inside this we have cot x minus cosec square x. Now we don't have any problem up till now. Dx will bring upstairs on the left and dt remains on the right. Now integration. Now this I and this I and this I on the left we just got. All of them are similar. All of them are same. See, the cheese comes from milk only. So our question is milk and I which I formulated is our cheese. So this is also cheese. So it's the same as question only. So you can just write I in this place. This is I, so just write it as I. And on the right it will be integration of dt plus c. This will give you t plus c. What was t? We assume t to be erase x fx. So just write this erase x and in place of fx it is cot x plus c. Now this step, this method or this method, they both are true. So this is the way you are going to proceed. So you can follow this solution. Tan log x plus sec square log x. Now we don't have any erase x here. But log x and erase x are so much related that you can transform one into another easily. So this is the beauty of this log x and erase x. So in order to solve this question, we need erase x and that will come from where? From log x. So we'll assume log x equals to t. So we assume that this log is base e. For example, if we just write this log base a b equals to c, this is nothing but a to the power c is b. A to the power c is b. In the same way, log base c x equals to t is e raised t equals to x. So let me write this. X equals to e raised t, and this is what we are going to use. Now we'll differentiate now. Okay, so just differentiate d by dx by dx equal to e raised t. So dx will be equal to e raised t dt. Now this all has been done in order to change this particular integral in the form of e raised x into fx plus f dash x. Alright. So this tan log x has been changed now to t because this is 1, this is 2. So we have taken t as log x. So you can just replace log x by t. plus sec square. Now here also log x can be replaced by t. So this is integration. Now when we come to this dx, that is why we started all this, because dx can be written as e raised t dt. Now e raised t is also with us. You can call it as e raised x. Tan t is fx because the differentiation of tan and t is sec square t. So you can write it as f dash x. So just write this as f dash x. fx plus f dash x. So all of this done just to equate this tan t with sec square t. So we can write it as e raised x fx plus constant of integration. That can be your final answer. And in place of fx, you can replace this fx by tan t, because this is e raised t ft dt, ft plus constant of integration. So e raised t ft is nothing but tan t. So let's write tan t here and plus a constant of integration. Now from here, in the beginning we assume log x equals to t and e raised t can be replaced by x. So here x and tan t will be equal to log x. You don't have to write this base e all the time. This was just for your explanation. So tan log x plus constant of integration. So this is how it's going to be solved. So if e raised x is not there, then these are the ways you can create e raised t, because it was not there. E raised x minus 4 divided by x minus 2 whole cube. So we need to convert this x minus 4 divided by x minus 2 whole cube in the form that we get fx plus f dash x into e raised x. So keep it inside an integral sign, and that will give you e raised x fx. So x minus 4 can be written as x minus 2 minus 2. So it will be minus 4. So we'll separate them out using the denominator x minus 2 whole cube. X minus 2 whole cube now. So we need to separate them out. X minus 2 divided by x minus 2 whole cube minus 2 divided by x minus 2 whole cube. This gets cancelled, so you will just be left with x minus 2 whole square. On the right it will be 2 divided by x minus 2 whole cube. So this fx, let's assume this as fx. It's 1 by x minus 2 whole square. Now when we differentiate this, we'll get x minus 2. If you take this upstairs, it will be x minus 2 to the power minus 2. So minus 2x minus 2 minus 2 minus 1 and x to the power n minus 1 I am applying. And then you have to differentiate x minus 2 also, and that will give you 1 only. So finally you have a negative 2, and in the denominator it will be x minus 2 whole cube. This is f dash x. This is the differentiation of 1 by x minus 2 whole square. So if I just add these two, fx and f dash x, and then it is preceded by e raised x, this one, and then you put an integration sign. What is the direct result? It's e raised x fx. And what was fx? 1 by x minus 2 whole square. So e raised x into 1 by x minus 2 whole square you can write. And this x minus 2 whole square plus a constant of integration is your final result. Now if you want more explanation, this question carries more marks, then the process will be from here. We'll start from here. So this simplification has to be done that time. And till this step, the next step will be what? Now we'll assume this e raised x into fx, because we know that fx and f dash x is already there. So e raised x fx equals to t we assume. Then we differentiate both the sides. So let's differentiate this. E raised x minus 2 whole square. We are differentiating e raised x. We are applying the product rule here. Now we'll differentiate 1 by x minus 2 whole square. And that will come as negative 2 divided by x minus 2 whole cube. E raised x will remain there. Equals to dt by dx, because we are differentiating here. We are taking e raised x common here. 1 by x minus 2 whole square minus 2 by x minus 2 whole cube. And dx will bring upstairs on the left hand side. And then we'll integrate both the sides. So when we integrate both the sides, you'll see left hand side you don't have to integrate, because this is what? This is the original equation. If you follow this arrow sign, this has come from e raised x minus 4 by x minus 2 whole cube only. So let me write this only. And this is equal to, when we integrate it with respect to dx, it will be integration of dt. And this is I only. So this is I, integration of dt will be t plus constant of integration. What was t? It is e raised x by x minus 2 whole square. So e raised x by x minus 2 whole square plus constant of integration. Okay. So this is the reference. Those who are solving by themselves, they can have a reference here. And you can solve it this way. Now e raised 2x into 1 minus sine 2x divided by 1 minus cos 2x. First thing is that we need e raised x here. How can we make this e raised x? Because we are actually witnessing 2x, 2x, 2x 3 times. So we can take this 2x as t. So this question has a different approach from the question we have already done. So let us assume t equals to 2x. Then we differentiate both the side. Dt by dx will be equal to twice. It's 2 only. Dt. Dx we are bringing on the right, so it will be 2 dt. No, 2 dx. So dx will be replaced by dt by 2, wherever it is. Now this expression will become like this. Integration of e raised x. What will be 2x? It is t. 1 minus sine 2x. So 1 minus, in place of sine 2x, you can write 2 sine x cos x. First, we can just replace this 2x by t. So everywhere you can see t now. And in place of dx, we will write dt by 2. So half goes in front of integration sign. Now this 1 minus sine t and 1 minus cos t can also be separated. But you can write this sine t as 2 sine t by 2 cos t by 2. And this denominator, first, it can be replaced by 2 cos square, no, 2 sine square t by 2, because 1 plus cos t is 2 cos square t by 2, 1 minus cos t is 2 sine square t by 2. So now separate these two terms, 1 by 2 sine square t by 2, and this is negative 2 sine t by 2 and cos t by 2. In the denominator you will have 2 sine square t by 2. So 1 by 2 sine square t by 2, you can take it upstairs. It will be cosec square t by 2. Now don't be tempted to cancel these two. You can just cancel this sine and sine. So 1 by 2, which is in the denominator, we'll just take them outside. Because 1 by 2 is already there. 1 by 2 I am taking from these two terms which I am talking about. Now sine you can cancel. Cos t by 2 sine t by 2 will become cot t by 2. So you can write this as cot t by 2. And 2 is already there. Now why I kept this 2? I didn't cancel it. Because now you'll see that this will be, because e raised t is already there. So this integration sign, I'm just inserting this e raised t just to show you that 1 by 2 and 1 by 2, 1 by 4 will be formed. Cosec square t by 2 minus 2 cot t by 2. Now assume this negative 2 cot t by 2 as fx. So what will be f dash x? Now minus 2 cot t by 2, when it's differentiated, negative 2 will remain like that. Cot t by 2 will be minus cosec square t by 2. And then the differentiation of t by 2 will be 2. Minus will be plus, 2 gets cancelled, only cosec square t by 2 will come. So now you see that if you assume negative 2 cot 2 t by 2 as fx, then f dash x will be cosec square t by 2. E to the power t is already there, which I inserted. It's seen very small, but it is there. So what is the result? Because if you have this related to the formula, you can just write e raised x fx plus c. E raised t, because all t is there. So e raised t, and we have assumed fx as negative 2 cot t by 2. So negative 2 I am bringing here on the left and cot t by 2 on the right of e raised t. Plus constant of integration. And now you have to replace t by 2x, because t was introduced by us. We need to replace it. So wherever t is there, I want to write 2x. So negative 2 e raised 2x cot x plus constant of integration. But 1 by 4 is also there. 1 by 4 was also there. Okay, 1 by 2 was already there. Then 1 by 2 came up, and then this will be multiplied by negative 2. So negative 2 multiplied by 1 by 4 is negative half e raised 2x and cot x plus constant of integration. Now this is the reference you can use, and there are certain other ways also to do this. This is what you can also follow. But the logic you understood. Now this exercise is over. Thank you so much.